Thank you very much. Good afternoon. I'm Konstantin. I'm going to talk about information design in the principal agent problem. It is a joint work with Yakov Babichenko, Inbal, Talgam-Cohen, and Haifeng. We'll start by providing some background, then I'll present the formal mathematical model, then I'll present the results and discuss some related papers, and finally I'll mention some interesting open questions. So what's contract design in general? So there is a principal, say an employer, and an agent, say an employee. And the employer tries to incentivize the employee to act in a certain way. So the employee can, for example, select the effort level to invest in a certain project, which could be to work hard, to invest some moderate effort, or to laze. And each effort level induces a distribution over possible outcomes for the projects. So, for example, it could be either the project is a success or a failure. And the employer only observes the outcome. For example, the project is a success, and the income of the employer is also just based on the outcome. So since I'm the last speaker of the session, I think it's perfectly fine to skip the numerical example. But in general, what is the setting of the contract design? So as I've already said, there is an agent such as an employee that can choose one out of several costly actions. And each action uses a common knowledge distribution over the outcomes. And the principal, such as the employer, only observes the outcome, which specifies the income of the employer, or in general, the principal. And to incentivize the agent, the principal pays the agent based on the outcome according to some contract, which I'm about to define soon. So what's new in our setting? What would happen if, rather than studying a pre-specified mapping of the actions to outcomes, we would introduce a third player, a regulator, or a social planner that would decide on some information structure that maps actions to outcomes in some noisy way. But the regulator has complete freedom when choosing this mapping of the actions to the outcomes. So let's see 3 motivating examples. So for example, the regulator can be a company that decides on a supervision policy that a direct manager is allowed to use to measure the performance of a worker. Or the regulator can be an examination authority who designs some standardized examination that is used by an institute to evaluate potential candidates. Or the regulator can be a software company that develops a software that automatically analyzes the speech of a salesperson in some call center and evaluates in performance based on this analysis. In the general principal agent setting, the outcomes have a dual role. First of all, of course, they specify the principal's income, but also they provide the principal with some information about the action of the agent. But in our model, the outcomes are only responsible for the latter. They only provide information for the principal about the action of the agent, and therefore we'll refer to them as signals from now on. Not outcomes, but signals. Our first research question is, given that the regulator has a complete freedom of choosing the information structure, which actions of the agent can be possibly implemented, meaning that the optimal contract would induce these actions. And we ask the same questions for the utility profiles, meaning the utility profile is just a pair of the utility of the principal and the utility of the agent. And our inspiration was the celebrated paper by Bergman, Brooks, and Morris on the limits of price discrimination, which studies very similar questions, but in the setting of monopoly pricing. So essentially, we try to do the same in contract design, and even though the methodologies are completely different, our results are actually somewhat similar. So we also get a neat characterization for implementability that are based on some very simple thresholds. So let's introduce the formal model. So as we usually have in a contract design setting, so there's an agent who chooses an action between 0 and n. where the 0 is the default action, or you can call it an outside option. And we assume that the cost of the 0 action is 0, and the other actions are sorted without also generality according to their costs in a non-decreasing magnitude. And the principal respective incomes for the actions are 0 to Rn. And as is natural, we assume that there are no two actions that have the same income for the principal and the same cost for the agent. And what the principal observes is one of k possible signals, not the actions themselves. But so far, it's just the standard principal agent setting. What's new in our paper is the notional information structure. So
I think we have this.
yes, please.
Does the principal observe his own payoff?
So the principal knows the payoff, or we call it the income of each action, but the principal doesn't observe the action themselves. So only signals, and how the actions are mapped to signals. Well, we introduce a third player called the regulator, and the regulator has a complete freedom of designing it.
But they cannot condition on the income to the payoff, to their own payoff. The principal cannot condition the income on.
So essentially, if we set it to the terms of the standard setting, then the income is just the expected payoff of the principal gross of the monetary transfer to the agent in expectation over the outcomes, as specified by the mapping of this section to the outcomes. Okay. So the information structure is a row stochastic matrix in which each row corresponds to some action, and it specifies the mapping of this action to the signals. So just a distribution over the signals for this specific action. And we assume that if the agent takes the default action 0, then it's just revealed to the principal. And the information structure is selected by a regulator with a complete freedom for the regulator. Now, as usual, a contract is just a real vector in which each coordinate is just the monetary transfer that the principal pays to the agent when the signal is specific. And a common assumption in contract design is limited liability, which means that the principal is not allowed to charge the agent. And we studied a setting both with and without limited liability. Let's first focus on the principal's perspective. So for each action A, let's denote by TA the expected monetary transfer that the principal pays the agent when the action is A, and the distribution is according to the information structure. And for the default action, the monetary transfer will always be 0. The principal is risk neutral, so the principal's utility is just the difference between her income RA for the specific action and her monetary transfer in expectation for this action. And of course, the principal chooses the contract that maximizes her expected utility. Now we distinguish between two types of agents. First, let's talk about the risk neutral agent. So for risk neutral agent, her utility for an action A is just the difference between the payment of the principal to the agent for this action TA and her cost for this action CA. And we also define the social welfare to be just the sum of the utilities of the principal and the agent for a specific action. So the social welfare of action A would be just the income of the principal for this action A minus the cost of this action to the agent. But there are also risk-averse agents. And to capture their utility, we adopt a standard approach based on a von Neumann-Morgenstern utility function. So there is some function V that must be concave, strictly increasing, get the value of 0 on 0. And it cannot grow too much when it approaches infinity. It grows very slowly near infinity. And the utility of the agent this time would be the expected value of V evaluated at the corresponding monetary transfer of the principal to the agent minus the cost of the action. The principal-agent interaction is a Stackelberg game. First of all, the principal chooses some contract. that maximizes the principal's utility, assuming that the agent picks the best action given this contract. And indeed, we also assume that given the contract, the agent chooses an action maximizing her utility. We consider a pure subgame perfect equilibrium of this game, and as a standard, we assume that when the agent is different between two actions, the ties are broken in the principal's favor. Now let's define implementability. We say that an information structure defines a utility profile, which is a pair of principals and agents utility, if this utility profile arises at some equilibrium. We also say that an information structure implements an action transfer pair, AS, if some equilibrium induces the action A, and the corresponding expected payment of the principal of the agent is S. In the paper, we characterize all the implementable utility profiles and also all the implementable action transfer pairs, both with and without limited liability, and both for a risk-neutral and a risk-averse agent. Now let's discuss our results. So first of all, let's talk about the risk-neutral agent. And let's talk of all the possible but not necessarily implementable utility profiles. Given some action I, and some monetary transfer S, the utility of the principal would be her income Ri for this action minus the monetary transfer S, while the utility of the agent would be the monetary transfer S minus the cost Ci. And to this, we should add a trivial utility profile for the default action. Now let's try to understand what are simple necessary conditions for implementability. So first of all, by the principal's individual rationality, the utility of the principal must be at least as high as the social welfare, which is also just the income of the principal for the default action. And of course, also the utility of the agent must be non-negative. But it's also easy to see that the utility of the principal must be at least as high as the social welfare of the least costly action. And this is because there is a very simple contract which just pays, regardless of the signal, the cost of the least costly action. And it is exactly sufficient to cover its cost for the agent, and therefore it reduces the least costly actions. So the base contract for the principal can do only better. And it turns out, surprisingly, that these simple conditions are also sufficient. So for a risk-neutral agent with limited liability, the utility profile XY is implementable if and only if X is at least as high as the welfare of the default action and the least costly action, and Y is non-negative. And we can also derive simple condition for implementability of action and expected transfer, but we're not going to discuss it. And without limited liability, we have a very similar result. So the set of implementable actions stays the same, but the utility of the agent must be 0. So as a simple corollary of this, we can, and also I should mention that binary signals are also sufficient to implement any implementable action or pair of action and monetary transfer or utility profile. And as a simple corollary, if the regulator is strategic and we would like to maximize the regulator's utility, then the only constraint is that the welfare of the action must be at least as high as the welfare of the default action and the least costly action. That's it. So it allows the regulator to maximize any function that she would like. Now for the risk-averse agent, here we can see a superset of implementable utility profiles. And why is it a superset? Because if Z is an expected monetary transfer from the principal to the agent, then her utility X would be her income minus this transfer, and the utility of the agent Y would be at most V evaluated at the expected transfer minus the cost, y at most because v is concave. So this is a simple corollary of adjacency inequality. So this set phi for a specific action is just the points below the graph of some concave function, which is a shift of v. And if we would like to think of all implementable actions, that first we'll have to take the union over all such sets phi, and add the trivial utility profile for the default action. And now, what would be the necessary conditions for implementability of a utility profile? So again, by individual rationality, the utility of the principal must be at least as high as the welfare of the default action, and the utility of the agent must be non-negative. But also we have a condition on the utility of the principal that is based on a simple contract that always transfer, regardless of the signal, the inverse function on v evaluated at the cost of the least costly action. And why is this? This cost, I mean, this transfer, or the inverse function of v evaluated at C1, it exactly suffices to cover the cost of the least costly action C1. And therefore, it implements this action. And the corresponding utility of the principal would be her income for action 1 minus this transfer, so she can only do better for the optimal contract. And again, turns out these bounds are also sufficient. And I'm not going to discuss the conditions for implementability of actions and monetary transfers due to the lack of time, but they are also based on these conditions. And here you can see that the set of all possible, but not necessarily implementable utility profiles is the union of the set of points below some concave functions based on v. And if you want to talk about all the implementable actions, then you just have to use the threshold, cutting the utility of the agent at 0, and the utility of the principal at this value that was originated from the contract that implements the least costly action. We have some further results for constrained regulator. I'll just mention that we have both a positive and a negative result. And it's indeed natural to study constrained regulators because, for example, in the employer-employee example, inherently the employer can induce some information about the performance of the employee. So maybe it's not possible to use an inference structure that is totally uninformative. Okay, so as for the related work, I'll just mention that we have a follow-up paper by Lin and Zhang that is zooming in on some objective functions based on our characterizations. So to conclude, we give a full characterization for implementability of utility profiles and action transfer pairs in the principal agent problem by any information structure picked by some regulator. And we also have by a positive and a negative result for constrained regulators. And there are plenty of open questions that are mainly based on a constrained regulator. And also we can think, for example, on combinatorial contracts. What happens if the agent is allowed to pick more than one action? Thank you very much for your attention.